Hey guys, this is Coach Brian bringing you the 11.4 geometry notes. 11.4 deals with composition figures. So composition figures are just when you have a shape that's made up of multiple shapes. That's really the best way to think about it. And you're trying to figure out either missing area, or you could be figuring out, a shaded area, or you're trying to figure out, an overall bigger shape, but a little piece is missing or something like that on most of these problems. So we're going to jump right into this. You can see on question number 1, it says determine the area of the shaded region. So we're trying to find all of this, and that by itself is not like a typical shape that we deal with. So what we want to do is we wanted to divide this into smaller shapes. So one thing that I said to my students was think about it like layering. Okay, I've got a rectangle as my first layer. I've got a rectangle as my first layer, and it's what's shaded. And then on top of that, I have put this triangle. And that's how I got the shape I'm currently at. So what I need to do is find the first area of the overall shape, and then find the second area, and I need to subtract them, because if I take away the triangle from the rectangle, it will leave me with the shaded area. Kind of took out more than I wanted to right there, but that's okay. Shaded area only. Okay, so I am first going to get the area of the rectangle. Area of a rectangle, it would probably be really helpful to have your 11.1 notes by, or a formula chart nearby. But the formula for the area of a rectangle is length times width, or you could also say base times height. And then the area of a triangle is going to be base times height over 2. So looking at this, we can see that we are missing this side of the rectangle, which is also corresponding to the base of the triangle. I don't have either one of those. So what I need to do is I need to figure out what that base is first, so that I can then figure out the area of both of these shapes. So to figure out this base, I need to look at what information they've presented me with. I know for sure this is a 90-degree right triangle with a height of 9, and because this angle is 90 and this one's 32, it means this missing angle is 58, because remember, all of the angles inside of a triangle add to 180 degrees. So when you get mixed information like this, you have some angles and some sides. Some angles, some sides. You're going to have to use trigonometry. Now, for SOHCAHTOA, remember that means sine, cosine, and tangent. I am looking for this side of the triangle. That is what I'm looking for. That is not the hypotenuse. So since I don't need the hypotenuse and I wasn't given the hypotenuse, I'm not going to use either one of the trig functions that requires the hypotenuse. I'm going to use tangent. And then you could set this up either using the 32 or the 58, and I'm going to use the 58. I'm going to say that the tangent of 58 equals opposite, that's the side I'm looking for, over adjacent. That's my next door side. So opposite over 9. The reason I set it up like that is because I'll multiply both sides by 9, and that will cancel out. And I'll have 9 times tan 58. And when you're putting this in your calculator, you need to make sure it is in degree mode. And so I'm going to do 9 times tan 58, and I get 14.4. And trust me, I know there's a lot of steps to this. So this is 14.4, which means the entire thing is 14.4 twice, 28.8. And if you notice, our instructions say round your answer to the nearest whole number. So you shouldn't be surprised that we're working with some decimals, but you don't want to round until you actually get to the final answer. So here's why finding the 28.8 was helpful, because it's this side of the rectangle and it's also the base of the triangle. So now what we need to do is we need to find the area of the rectangle, base times height, and then we're going to subtract the area of the triangle. So I'm going to put rectangle, and we need to subtract the triangle, which is going to be base times height over 2. So starting with our rectangle, it's going to be 28.8 times 18. 28.8 times 18. And that's going to give us 518.4. And then our triangle is going to be 28.8 times the height, which is 9, over 2. So 28.8 times 9 divided by 2 is 129.6. And then we're going to take 518.4, subtract 129.6, and we get 388.8. Now the instructions did say round to the nearest whole number, which is our ones spot, and since this is greater than 5, we are going to round up to 389. We're going to go back over here and get our unit of meters and its area, so it's meters squared. I know that was a lot, so just to recap, we did missing base first by using trig. Once we had the base, we found the area of the rectangle, the area of the triangle, and then we found the difference between them to find the shaded area. Now, you can do the you try it on your own, but you'll see they already give you the base, they already give you the height, and they already give you the width of the rectangle. So you actually already have all the numbers you need, and you can just jump straight into the area of the rectangle minus the area of the triangle. All right, moving ahead now to number 2. It says determine the area of the shaded region of the composite figure. So we're trying to find all these little exterior regions. They're all little odd shapes. They're not semicircles. They're not like a full portion of a circle. So what I want to do is figure out if this is composite, what are my two shapes? So again, think of this as like layers. What's layer 1? Layer 1 is a circle, all right? Perfect circle that's shaded in. Layer 2 is a hexagon that is inscribed in that circle, okay? It's a hexagon inscribed in the circle. So the next thing is going to be, if I have these two shapes, I need to be able to find the area of one and the area of the other and find the difference between them. So first, let's start with the circle. Area of a circle, again, this comes from your 11.1 notes, is pi times radius squared. Area of a hexagon, this comes from our, I believe, 11.3 notes, is going to be apothem times perimeter over 2. So just looking at this, it says answer in terms of pi. That means pi will be in our answer. We will have a pi symbol in our answer. So let's start with the circle since it's the overall bigger shape. First, I need to find the radius. The radius goes from the center of a circle to the edge of the circle. So in this case, they have given us our radius, and it is 13. So I'm going to say area equals 13 squared times pi. 13 times 13 is 169 times pi. That is the area of our circle. Next, I need to find the area of the hexagon. And again, they've kind of made this easy for us because from side to side is 24, and I'm trying to go from halfway to side. So that means it's going to be half of 24, which is 12. So my apothem is 12, and I need to find the perimeter. So for the perimeter, I need to get some kind of exterior value. I can do that by using the Pythagorean theorem on this triangle that I'm currently shading in yellow. So it's got 3 sides, and 2 of them are given to us. So we would do 12 squared plus b squared equals 13 squared. Write that in a different color so it's a little easier to see. 144 plus b squared equals 169. Subtract 144. B squared equals 25. How do you cancel out an exponent? With a root. So b equals 5. So that means this short side of this triangle is 5. Why is that helpful? That 5 is half of this side, which means the 2 halves together are 10. And then for this triangle, there are 1, 2, 3, 4, 5, 6 sides that are all 10. 6 times 10 is 60. 12 times 6, 72. Add a 0 over 2. 72 divided by 2 is 36. Add a 0. That is the area of our hexagon. So we have the area of our circle, we have the area of our hexagon. Now we need to figure out the shaded part, and that's what's left when you take the circle minus the hexagon. Circle minus hexagon. So I'm going to say 169 pi minus 360, and I can't go any further than this because these are unlike values, and it says answer in terms of pi. So I'm expecting to have pi in my final answer. So the last thing I'm going to do is put my unit feet, and since it's area, it's feet squared. That is my final answer. I'm not going to do the next one for you, the you try it, but I am going to give you a hint that should be really helpful. First of all, this is a circle inside of a pentagon, okay? Pentagon. So you're going to need to find what's left when you do the pentagon minus the circle. And for the pentagon, you're going to need the apothem, the perimeter, and 2. Well, right here it says that the sides of the pentagon are 17.4, and also the apothem is 12. So you have the 2 numbers you need right there. Next, for the circle, it's pi times radius squared, and the radius, since the circle is inside the pentagon, the radius is from the center to the side. So again, it is 12. So that's about as set up as I'm going to get it for you. You need to find what's left over when you subtract them. All right, couple more. One more. All right, find the area of the shaded region. So first thing I need to do is figure out what shapes make this up. I've got a trapezoid. Okay, I've got a trapezoid, and I've got a right triangle. Right triangle. Now, I'm trying to find what's shaded. So that's mostly trapezoid, and I'm going to be taking away the triangles. So I'm going to do trapezoid minus triangle. First, what's the area of a trapezoid? Area of a trapezoid is base 1 plus base 2 times height over 2. Second, what's the area of a triangle? Base times height over 2. Now for both of these, you can see I need a height. 17 is not the height. It's not the height. This number is the height. And so I need to find that, obviously. And the only information I have to find it is the fact that it is the medium side of a right triangle that I know 2 of the sides of. So what I can do is I can use Pythagorean theorem, and I'm going to make my short side A. I'm going to leave my height as H, which would be my B. And then I've got my C, my hypotenuse, right there at 17. So A squared plus B squared equals C squared is going to give me 8 squared plus, I'm going to say H squared because it's my height, equals 17 squared. 8 squared is 64. 17 squared is 289. Gonna subtract 64. I get H squared equals 225. Now, that should already, just from our previous units, be kind of ringing a bell that the square root of 225, it's a perfect square, and it's 15. So my height is 15. That means where I need height here and here, that's going to be 15. The only other thing I need is my bases. So looking at our trapezoid overall, it's got a base, a top base of 16, and a bottom base of 8 plus 20, so 28. Looking at my triangle, it's got a base of just 20. So I have all the numbers I need now. It's just time to do the math. First, area of the trapezoid is going to be base 1 plus base 2 times height over 2. So 16 plus 28 is 44. 44 times 15 equals 660. 660 over 2 equals 330 meters squared. That's the area of my trapezoid, the whole thing. Now I need to figure out the area of the triangle. Area of our triangle. So it's going to be 20 times 15 over 2. This is our area of our triangle, by the way. 20 times 15 is 300. Divided by 2 is 150. So now the last step is I need to find the difference between them. Trapezoid minus triangle leaves me with 180 square meters. 180 square meters. Again, I'm not going to solve the next one for you, but I do want to point out some things. You have a trapezoid. You have a base, and a height, 6. You also have, I'm going to shade it in here, you also have a triangle in green, okay? It has a base of 10 right here. That's the base of my triangle right there. That's the base. Make it a different color. And it has a height. That height is 6. And I know that the 10 looks shorter than the 6. So just trust the numbers that you're given. Okay? Those are the numbers you need to solve this one. And then lastly, you'll need to do the written response for your teacher to grade. Describe how to find the area of shaded areas of shaded areas of composite figures. What steps would you follow? What questions do you need to answer? That's all the stuff we've been doing in these couple of examples. You're just putting it into words, okay? So describe what we've been doing, give it a good quality answer.